Good morning, everyone.
Morning.
Morning.
How are you guys hanging in there?
I'm all right.
All right. How many of you took a shot at scripting some regression R from scratch between Monday and today?
I did.
How did it go, Grace?
I didn't think it was too bad, actually.
Okay. So you were able to generate code that would give you the model and
Yeah,
also code that would give you the ANOVA table?
Yes. Wait, the ANOVA table? Wait, let me see if I did the ANOVA table.
Once you have the model created correctly, it's just a matter of whether you're asking it for summary or summary.AOV.
Yes, I did that.
Okay, cool.
Okay.
All right.
Wait, no, I didn't.
Were you able to generate a meaningful graphic?
Yes.
Why don't you share your screen with us?
Okay. I actually don't have the analysis. Can everybody see that?
You don't. I can see it. What do you mean you don't have the analysis?
Do I not have the analysis? I mean, I have the summary of this.
Yeah. So just run line 8. Yeah. So when you go back to when you ran line 9, it's basically just giving you the y-intercept and the slope. But that is not the y-intercept and the slope that I got. That's weird. Take your relative humidity and weight loss out of quotes. Oh, here's the other problem. What's the other issue that you have with your model? Can anyone help her? Anybody in the class? Unmute yourselves and speak. Can you guys all see her screen?
Yes. Yeah, but I got nothing. I don't know.
I don't
Oh,
know.
you got it.
I don't know if this is it, but I know sometimes like you have to put like beetle $sign in front of like relative humidity and weight loss.
You don't in these packages where you're just basically running data.
Okay.
But there's a fundamental problem. So we got a really small slope value when we ran these data before.
What if she flipped weight loss and relative humidity? Have weight loss go first?
Yeah, weight loss always comes first. So your dependent variable always goes before your independent variable in the equation that you're writing. Yeah, there you go.
So
That should be weight loss. Yep.
Dependent goes first?
Dependent variable always goes first, whatever your response variable is. So in regression, if weight loss is responding to relative humidity, or in tick size, the tick size is responding to different types of hosts or whatever. Yep, that's the right slope value. Okay, so whenever you just type in linear mod, it's not going to give you anything more than what the model is. And the model is a y-intercept and a slope value. The slope value is called relative humidity because that's what you multiply times relative humidity to get what the y variable is, what the response variable is. Now, when you type summary linear mod, you go ahead and activate that. Now you get a bunch more information. You still get what the intercept is, and you get what the slope value is, but you also get a significance test as to whether that intercept is different from 0. Also a test to see if the slope is different from 0. In this case, it is. It also gives you your R-square value down there at the bottom, 97.45. So this knowing something about variation in relative humidity tells you a lot about variation in weight loss. And it also gives you the F statistic that you calculate, as well as the degrees of freedom and the p-value for that slope. So the thing that you haven't done yet is do, on line 11 of your script, do summary.aov linear mod. 2 R's in summary.
Oh,
I know it's like oh, sorry, 2 M's rather. It's like having a terrible backseat driver over your virtual shoulder. So when you do summary.aov, it presents the information in the ANOVA table that you would normally calculate for the statistical test of the slope. And what you see is that the F value for that is 267.2, which is just like it is in the summary, just above that. So that is exactly what you're supposed to be doing. Does anybody from the class have any questions for Grace? In your participants tab, if you got basically what Grace got, click yes.
How do I click yes?
You go down to the bottom of your screen, there's a participants tab. It says manage participants.
Mm-hmm.
Click on that and it will give you a little box. And so there's one no person. Who didn't get it?
That was me.
Oh, Bryce. Yeah. So Bryce, what questions do you have?
Well, okay, so I did mine a little bit differently, and I got the table and I got the ANOVA table, but my results were different, and yeah.
Seeing Grace's, can you tell what happened?
Honestly, no. I mean, so
Grace, unshare your screen and Bryce, share yours.
So here's what I need to do. I'm using Zoom on my iPad, and so what I'm going to do is switch over to the computer that I'm on and then share my screen.
Okay.
So
right.
I'm going to come back.
Okay. We'll give Bryce a couple minutes to get reconfigured, and then everybody but Bryce, and including Bryce actually, go to the Moodle site and download the COVID 2020 data set that I've put in there, and put it in whatever folder you're normally running your R scripts out of. Bryce, are you back with us?
Yes, but I'm trying to figure out how to get it on my computer. Like the Zoom, because I'm still...
Oh, get Zoom. Okay, all right. That's actually going to be an involved process. You're going to have to download the app, et cetera, et cetera. So we'll just move on.
Gotcha.
But,
Okay.
At some point, you should probably be zooming in on your computer because occasionally I will ask you to do things like share your screen or something like that.
All right. Yeah, that's fine. I can do
So
that later.
so do you have your R script up on your computer there?
I do.
Okay. Copy the model into the comment section. So there's a chat function in Zoom. Just copy your line of code that was designed to give you the model, and
Okay.
we can take a look at what you have. So just copy and paste.
Sure.
So many ways to do things.
Honestly.
And then the rest of us can look at what your line of code is, and then we can help you figure out what is perhaps going wrong. So Grace,
Yeah.
are you willing to reshare your screen while we go through the graphics?
Yep.
Okay, cool. Awesome.
You want me to go through this?
No, let's wait and look at Bryce's code
Okay.
before we move on to graphics. Oh, but wait, Bryce, you're doing this on your computer. Never mind. You're
Okay.
zooming on your iPad, and on your computer is where your code is. Never mind.
Okay.
Can you type it in?
Yeah,
on your
that's what I
iPad?
was doing.
Okay, all right, do that.
Okay.
So Bryce admitted that he didn't get the right answer. I don't have any responses from Athos or Brady or Chase or Connor as to whether their code worked.
Good morning, Dr. Klominski.
Morning.
I got all my R matching my hand calculations, which was nice. But,
Okay, for the Beetle data set?
for the homework or the report due Friday?
The linear regression model.
Oh, yeah.
The Beetle data set.
Mine was right, yeah.
Okay, so you're not actually asking it to do a plot, Bryce. You're actually asking it to run a linear model. So
Right,
in front of that
I
should be.
I was gonna say I tried to hit enter thinking that it would like give me another line, and then it just sent it into the chat.
Okay.
But I was like watching a tutorial on it, and that was basically like I watched a few of those to figure it out, and that was the first thing that they did, and then
Oh yeah.
I didn't know if it was going off of that plot.
See the data. Yeah. So I need whatever the equivalent is of Grace's line 8. How does your line 8? And I'm pointing at it on my screen, realizing
Yes.
you can't see my arrow. Because it's Grace's arrow. Grace, point to line and point to where. Oh yeah, there you go. Yeah.
All right.
So how did your attempt to get the regression model to run differ from Grace's?
I had. Oh, actually, mine was very similar to that. It was just like titled a little bit differently.
Because you have different variables in your data
Yes.
set?
Actually, no.
Variable
I think that mine were all the same. Relative humidity, and actually mine was just humidity, and then I kept the same data headings that you had.
Okay. So did you ask it for a linear model, or did you ask it for something else? Did you put LM in front?
I put LM, and then I basically had the same thing as her line 8, and then under that I had summary, and then in parentheses I had entitled that line 8 to like Beetle regression. That's just what I named it, and then I did summary of Beetle regression, and then just now I did summary AOV Beetle regression, but my initial summary of that was different.
Oh, so you're getting a different result.
Yes.
Okay, go back and check. One of the things you should always do is go back and check the original data file. You might have miskeyed something in when you were transferring the data into a CSV file or something. So that might account for it. Maddie, can I tell them about our experience yesterday?
Yeah, that's fine.
So Maddie got together with me yesterday morning about the ANOVA work, and her data weren't matching the R output at all. And the R output that she was getting wasn't matching the R output that I was getting. And so we were troubleshooting things, and it turns out that she had one keystroke error in the data that she used for her R script. She had changed the first value from 68 to 63. And that difference of 5, whatever it was. What was the data set, Maddie? Oh, it was the number of shards, wasn't it?
Yeah, it was the first question.
Yeah. So that difference in 5 changed the value of that combination of shard and site, shard and region. That changed the overall mean, and changing those two means propagated through the data because you're always comparing things either to the combination row column mean or the grand mean, and that propagated through the entire data set. And because all of those differences get squared, it led to really big differences in the sums of squares that you got. And then when she did her hand calculations, she had more keystroking errors. And as a result of that, that thing was really messed up. So I think I told you this a couple of time periods ago in our Zoom meeting, that whenever I have students enter data, I have them enter the data set twice. And then we set the two versions next to one another, and we subtract one column from the other column, and we're looking for differences. And that's the easiest way to go about finding keystroke errors, because the chances that you make the same keystroke error 2 times entering the data on 2 different occasions, those odds are really small. You still might have some keystroke errors in there after you've done this, but that will generally find most of them. And my students always complain because that seems like doing twice the work. So my partner, who is a geneticist who works at KU, she's talking to the guy who's the PI in the lab that she's working in. She's actually talking to one of the graduate students, and one of the graduate students came to her and said, you know, how do you make sure that you're not making keystroke errors? And Elizabeth said, I entered the data twice and then compare columns. And so then the graduate student went to the PI in the lab and said, Dr. Everman said to enter the data twice, whereas you told me to just enter the data once, print it out, and then compare it to the original data sheet. He's like, yeah, don't do that entering it twice. That takes a lot of time, and you can find them the other way. And so people have different opinions about this, except that I've used the enter it once and then compare it to the data sheets, and I still miss keystroking errors when I do that, because I'm a human, and humans are subject to not getting things found. So yeah, so that's correct the way you've specified that, Bryce. So the only thing that I can think is that you probably have a mistake in the original data. And
gotcha. I mean, I had just gone from the data file that like you had uploaded, and I didn't change anything. And I mean, if that's right, then I don't know.
Oh, that's weird. All right. At some point today, take screenshots of your output, and I'll take a look at it, and I'll email you back some ideas on maybe what's going on.
Yeah, sure thing.
Okay. All right. Grace, walk us through what your plotting script is doing. So expand out your window there so that we can see all of your script. And
Okay.
it looks to me like you've, for the most part, just basically done what I did.
Yes, I did what you did.
Okay, so would you always want to have that theme black and white up there at the top?
Do we always?
Yeah, how have I been doing that lately? This is a really old script of mine before I developed better, more efficient ways of doing things.
I'm not really sure.
I would normally take that theme black and white. I would put it down there with all the other theme
Okay.
statements. And then what would I do with that whole big block?
Put it before?
Yeah, I would put it at the top of the script and then just call it something shorthanded. Like I usually use TH. Go to the line above that. Nope, go back. Go to line 22, hit return. There you go. Now type it in. Nope. Just put theme black and white in there. Yep, there you go. Nope. Yep, now put a plus after that. Yep. Get rid of that TH at the beginning. Yep, and the assignment operator. So this is how you would normally do it if you were normally doing things where you have to write this into every plotting script that you have. But a more efficient way of doing that is to take all of those theme statements and do what to them? Somebody help her out. Oh, she doesn't need any help. She's going to do it herself. Yep. Now run that. Now.
Wait, was that right?
Hit enter.
Okay.
Go up to TH. Not that one. The next one. The one that you just built. Yeah, that. Now activate that. Oh, have you loaded ggplot yet?
Oh, I don't think I did right now.
Yeah, load your libraries.
There we go.
Okay, there you go. So now when you run your code, go down to your script that starts on 26. Now get rid of all of that junk.
Get rid of
all that theme stuff.
Oh, yeah.
And now just put a TH in there. And that will do the same thing. And it's just much more efficient, much more elegant. And now we can see your entire block of script that is telling you what to do. So walk us through what all of this means, line by line.
Okay, so this is our data, this is our X and our Y.
Okay, so in the aesthetic statement, you're having to tell it what X and what Y is. The AES stands for aesthetics. And in this case, aesthetics, you're just basically specifying the general parameters of the graph. Continue.
Okay. So geom smooth is like what the graph is gonna look like.
It's the method of drawing the line.
Yes. And so the method is linear model.
Mm-hmm.
And then the color of that will be black. And then geom point lets you adjust the point sizes and the colors of that. And then XLab is relative humidity. That gives you a big title for your overall X's. And then YLab gives you a big title for your Y axis. And then GG title lets you title the whole thing. And then
All
plus
right.
theme is from the up here.
Yeah, and you have HJustify under theme plot title element text. You have size and you have HJust. They're in line 19.
Oh, right here.
Yep, that HJust basically says to center it over the plot rather than right justify or left justify. Okay, let's see the plot.
Okay. Oh, wait. There.
Okay, there you go. So that's basically what it should look like. Now explain to everyone what that plot is showing us.
So basically your dots are your individual data points, and your line is the line of best fit.
Yep.
So it's just showing you, is it showing you your points like in relation to where the mean would be?
Yeah, so if you think of the model as showing as the predicted value being the running mean of weight loss as relative humidity changes, that line is the running average in a sense. What does the gray area to either side of the line mean?
You explained it on Monday, but I forgot.
Somebody help her out.
95% confidence interval.
Okay, so it's a 95% confidence interval of what?
At any given X value, you read up.
So at any given X value, so sure. But what does that essentially mean that is a 95% confidence interval of?
That at that X, you get one value of Y predicted by the formula, and that's on the black line, but it's not a perfect prediction. And so you'd have kind of like around that point, you have your own little bell curve. And
exactly, it would look exactly like a little bell curve as you move down the
line. Kind of arranged vertically, and it's got its own 95% confidence interval, and that's the vertical width of the gray band at that X value.
So because that gray band though shifts as you move across relative humidity, it's traveling down the weight loss scale, that 95% confidence interval actually ends up being a 95% confidence interval of what aspect of linear regression? At any given point, it is the 95% confidence interval for Y at that level of relative humidity. But across the entire scale of relative humidity, what does it end up being the 95% confidence interval of?
The residuals?
Nope. These are the elements of the line that is being predicted. You have a y-intercept, and you have a slope value. Is that 95% confidence interval a 95% confidence interval for the y-intercept?
It's the slope, right?
It's a 95% confidence interval for the slope. So Grace, do us a favor.
Okay.
Go to, I don't know, line 15.
15?
Yep. And type in mean, and then in parentheses, put relative humidity, the value relative humidity. But as it's written in your variable name.
Just like that?
Yep, run that line. Okay, you're gonna have to put your data file name in front of that.
Say Beatles, comma, or data equals?
Beatles, Beetle $. You're wanting it to do the mean of relative humidity in that data frame. Okay, do that. So 50.39. So imagine that there is a line going up from the relative humidity axis at 50.39, and it goes up and hits the line of best fit at that point. Imagine that that line is a fulcrum, and on that fulcrum, the line can teeter-totter. So at that mean relative humidity, the line of best fit is basically showing you a negative. I think this would be a negative relationship. So then the 95% confidence interval asks, at that fulcrum point, can you put a line of 0 and have it still be inside that gray 95% confidence interval? If you can, you should see a p-value that would indicate that you have a slope that is not significantly different from 0. But if at some point you start teeter-tottering that slope and it leaves that gray band, that means that you have a slope that is different from a slope of 0. So that's one intuitive way of interpreting what that gray band means. At the average relative humidity, can you fit a slope of 0, a line of a slope of 0 into that confidence interval? And if you can, then that line is not different from a slope of 0. And if you cannot, then that slope is a slope that is different from a slope of 0. Does that make intuitive sense? And once again, I have nothing but silence from you guys.
That does make sense, yes.
Okay. Anybody else have a question about that?
So a quick look would be, does the gray band include a horizontal line? Could
a horizontal line that has a fulcrum at the mean of the x variable.
Okay. And if it does,
then you should see no significant difference for the slope.
Then you do not reject the null hypothesis.
If the null hypothesis that you're testing is a slope of 0. Now, one of the cool things about regression is that doesn't have to be your null hypothesis. Your null hypothesis could also be, is your slope different from a slope of 1? For example, if you had some expectation of what a slope should be, you can test to see whether your slope deviates from any value of slope, for that matter. Other questions?
I have a question about the report.
Oh yes, the report.
Is the data replicated or not?
For the gecko data?
Yeah.
Oh yeah, we replicated the hell out of that thing.
Okay, so yeah,
like
so
you have tons of geckos that were in Galveston in the winter. You have tons of geckos that were in Galveston in the summer. You have tons of geckos that were in Oklahoma City in the winter, and you have tons that were in Oklahoma City in the summer.
Okay.
Yeah.
So we gotta run it. Okay.
Yeah, you have like 187 observations or something like that. Yeah, that's very replicated.
Okay. Thank you.
All right.
Can I see like more of what is included in the theme? Because when I'm trying to run it on R, it runs, but it gives me like a massive, like in the console, it gives me like 300 lines of like random junk.
Okay.
I think I'm doing something wrong.
Yeah, make sure that you've loaded ggplot.
Yeah,
before
I have.
you run it. Oh, you have. Oh, that's
yeah.
weird.
I mean,
because
okay.
Grace, go up and scroll down in the console. Scroll up in the console to an earlier part in the console when you were trying to run that line. No, in the console, down lower left. Continue scrolling. Continue scrolling. Oh, does it look like this jumbled gibberish?
Yeah.
Yeah, it was because she hadn't run ggplot before she tried doing this. So if that's what your jumble of mess looks like, it's probably because you haven't loaded the package yet.
Yeah.
Is it still doing it?
Yeah, it's giving me like a bunch of errors. Like, so I have commas after like lines 21 through 23, like she has, but it was like giving me errors that they were wrong.
Do you have your parentheses like this?
Yeah, you always have to. Okay, so that's usually a single error line.
Right there.
All right.
Okay, it says that there's an error in theme panel.grid.major. It says it's matched with multiple actual arguments.
Is your element blank?
Yeah.
Thing there, and there's nothing in that parentheses.
No.
And there's a comma after that.
Mm-hmm. Well, I don't have a comma after. Or yeah, I do, sorry. Oh, I figured out what I did. I typed major twice instead of minor on the second line.
Yeah, so that also causes our problems when you give it the same command twice in a common block. So yeah, so
okay, but I fixed it and it's still giving me the like junk at the bottom, even though I've reran ggplot.
Okay.
Like library ggplot 2. It gives me like when I run it, it gives me a graph. My graph just looks a little bit different.
Okay, so here's a way of troubleshooting. So anytime you're troubleshooting a script, so in this script, on line 17, there's a single command that basically converts this to a black and white graph rather than any other kind of graph. So one of the things you can do is just highlight theme BW and run that. And if that runs fine, there's nothing wrong with that. 18 and 19 are all one code. So you can basically highlight 18 and 19 and run that. And if that runs fine, it tells you that that's okay. And so it's possible to actually go through your code line by line. And when you do that, you'll be able to identify which line is causing the problem. And then you can concentrate on that part of the code. So that's what I'll oftentimes have to do when a particular script isn't doing what I want it to do, or it's throwing a bunch of error messages that aren't just informational, but are actually catastrophic error messages. So I would tear that apart line by line and see what the deal is. Now, if you do it single line by single line, you may find yourself having to get rid of some commas and add some parentheses and stuff like that in there. But you can run it line by line, and you should be able to figure it out. If you can't, then we can spend some time and we'll probably be able to figure that out.
Okay. Yeah, I figured out that it's in the second part.
The plot with all the X and
like
Y title.
Title equals element axis title.
Okay. So yeah, you might want to just then run that line by line and see, which line is the one that's screwing things up. And what it's going to be is it's going to be some simple typographical error where you left a comma out or something like that is probably what's doing it. This is the irritating thing about computers. You have to speak to them, and you have to speak to them clearly, or they will just not behave.
Okay, yeah, I'll try to figure it out. It's
okay.
Yeah.
If not, drop me an email. We'll figure it out together.
Yeah.
All right, Grace, unshare so that I can share my screen.
Okay. Can you see your own screen now? Okay, good.
All right. Oh, and thanks for doing that, by the way.
Yep.
It takes a little bit of courage to stick yourself out there and be subject to the ridicule and criticism of the professor. So I have a blank script here. So what I want us to do is to work on the COVID 2020 data set. So what's the first thing that I need to do after I've made sure that I'm in the right place on my computer?
Load the CSV.
Load the CSV. So I'm going to call mine dat. You can call yours whatever you want. What have I just done wrong?
You need quotes.
I need quotes, don't I? Good. After you've loaded your CSV, what do you want to do?
Look at it.
You want to look at it. And you can look at it by getting the header, the first 6 lines, or you can look at it by actually just having it put the whole data set there, or you can look at it by using the view command to actually open the entire data set in a different window. And you can see that I've done a little bit of work. These are data that I downloaded from the CDC website, and it gives you the date, it gives you the number of days. So starting on day 1, that was January 22nd, strikingly enough, and it takes you all the way through the 5th of April, which is the day that I downloaded this data. Now, what's going to be a potential problem with that data file?
Well, if you're trying to predict from it, if you've got data, but the data hasn't turned a corner yet, and so
okay, but I'm thinking more particularly in this column of data. Is there anything that you think might throw R a curve?
Yeah,
treat days as numeric.
What's that, Chase?
Could it treat days as numeric instead of a factor?
Well, but in this case, we actually want it to treat it as numeric because we want to run a regression on these data. What could be another problem that it would have with these data?
Are you going to want it to be able to read the date format?
You do want it to read the date format. So how do we find out how R is treating a column of data?
Class.
And in this case, we need to put the data frame and then the variable. And when we do that, it's treating it as a factor. So what we can do is we can get it to treat it as a date, which is what we want it to treat it as, using the assignment operator. And we can do as date. There is as date, and it's capitalized actually, as it turns out. And we just want it to treat that column as a date. And when we do that, we can go back up to line, whoa, what happened? Oh, as date, we did not give it some other information. So we got an error down here that says, error in character to date X, character string is not in a standard unambiguous format. So whenever you get an error code and you don't really know what the error code means, you can actually go over here and type in as dot date, and you can get information as dot date. And what we haven't done is we haven't specified what the format of this is. And so what we need to do in here is we need to tell it that it is not year, month, day, it's actually day, month, year. And so in quotes here,
I think it's month, day, year.
In quotes here, we want to do parentheses. Oh, it is month, day, year, isn't it? Slash day slash year. And when we do that now, no error. And when we go and redo the class command, it will hopefully tell us that it's now treating it as a date. Yay! Once again, we don't really care about the other column, the days column, because that's the number of days since the beginning of all of this. And we could have coded it with day 0 being the first day that there was a case in the United States. But as you scroll down that data frame, you see that things are relatively calm until around the 28th of February. And then all hell breaks loose. We go from 16 to 24 to 30 to 55, or 53 to 80 to 98 to 164. And at this point, we are now at 330,891 cases in the United States. So what's the next thing that we might want to do with these data?
You can maybe just plot them to see what they look like before I would assume you try to do some kind of regression.
Yeah, let's plot them to see what they look like. So we're going to plot the data frame DAT. The aesthetics we're going to use are the X variable is date, and the Y variable is total. This is why it's sometimes good to have the head of the data frame. Is that all we need? No, because when we do that, it's just like, oh, we haven't loaded ggplot for one thing. So we need to do library ggplot to get that up and loaded. Oh, it's because of ggplot 2. So, oh, I made a typo. So it ran it, but all it did was give us a blank box. Why?
You didn't give it any kind of, like, you didn't tell us to plot a point or anything.
I didn't tell us to plot a point, so we can plot points. How do we do that?
Just geom point.
Geom point. So if we scroll down far enough, we will find geom point. And if we run that, it gives us a bunch of black dots on a gray background. And that does not look linear at all, does it? So when we have, this looks like what type of a curve?
A bell curve, kind of. Well, it's going into one.
Well, it could be a bell curve, but from biology, we would recognize this as what type of curve?
Exponential.
What's that?
Exponential.
It's an exponential curve. So one of the ways that we can linearize an exponential curve into something that looks more like a line is by plotting this on a logarithmic curve, a logarithmic scale. And so how do we change the scale of y? I haven't actually taught you this because you've never had to do this before. We can use scale y continuous. And if you type in scale y continuous and you ask it to transform this into a log-based axis, it basically will change the scale on the y-axis so that now the y-axis is the logarithm of the actual data. Let's make this a little nicer. Let's do it log 10. And so there's 10,000, 100,000. So that's the scale now. Of course, it doesn't look that way because we haven't done anything else as far as the aesthetics are concerned. And once again, you see that it's closer to a line, but it's still not. And it's because in disease dynamics, there's this lag phase of the spread of the disease before the disease really takes off and starts to go exponential. And so when we did this logarithmic transformation, which would normally transform exponential data into something resembling a line, it only happens after the disease has spread enough in the population that exponential growth actually really takes off. And so we can see kind of where that break point was. It was there at the end of February, where the disease was not increasing in an exponential way, and now is suddenly increasing in an exponential way in terms of spread. So what does this tell you about the COVID pandemic in the United States? In terms of government trying to mitigate this mess. What should the government have done rather than what it did do? You guys still with me?
Yeah, I just really don't know.
So on February 29th, what were you guys still doing?
We're still going to school.
Still going to school, still going to class, still going to the movies, et cetera, et cetera. Back when you have this slow growth going on, that's when we should have been doing what?
Precautions.
That's when we should have been doing precautions. We didn't start doing precautions until mid-March, at which point we've already started this exponential phase of growth indicated by how this line converts from a shallow sloped line to a very steep sloped line. This represents where COVID in the United States all of a sudden started spreading really quickly, because there were now enough people in the United States who had it, walking around not knowing that they had it, that it started to spread at an exponential rate. And so in epidemiological data, you oftentimes see this break point. What was that, Tom?
The data, is it hospital admissions, or is it like confirmed cases? Or
this is actually confirmed cases. So this probably represents an increase in testing as well as
testing.
Spread.
Yeah.
And so if we had been testing people back at this portion of time, this might have been more of an exponential rise as well, because we would have better knowledge. And so then we would connect, this to that. And this rise here would have actually been occurring earlier, but because we didn't have good testing ability, we not only had a lag in the spread of the disease, probably, we also had a lag in our knowledge of what the disease was doing. And that's always a bad thing to have in a pandemic, is bad knowledge.
And it's got this 14-day latency period. So really, if we were catching a bug, we were catching the bug on the 15th of February.
Yeah, and because you weren't being tested unless you were showing symptoms that were consistent with COVID, virtually everybody who got tested back during this time period tested positive. But if you were in this period of time when you had the virus, but you weren't showing symptoms, you weren't getting tested because there was no reason to test.
No reason, right?
And so you were walking around with the disease, not knowing that you had it. And so these numbers were probably invariably higher than they actually were during this time period. So we're now up above 300,000, and you could do a regression analysis on these data. So you can write a model for this. I'll just call it model, and we would run a linear model. And what we are concerned with is how the total is influenced by days, for the data in the data frame stat. Now, this is not going to give you a very good fit. So it runs the model, but when you get a summary of model, you're going to see that it has a not very good R-square value. R-square value of 0.414. Day is a significant predictor of the total values, but if we were to add a line to this graph, let's not log transform this graph. Let's go back to the normal way of thinking about this. And how do we get a line?
It's just geom line.
It's not geom line.
Okay.
It's geom.
Point.
Nope. We already have geom point.
Geom smooth.
Geom smooth. Because what you're doing is you're creating a smoothing function. What's the method we're going to use?
LM.
LM. And do we need to do anything else?
Color.
We can tell it what color we want it to be if we want it to be a particular color, but we don't have to. If we don't, it'll just give us the default color, which I think is blue. And when we do that, we can see from this thing, is the slope significantly different from 0?
Yes.
Yes. Is it doing a particularly great job of defining that relationship?
No.
No, it sucks is what it does. So how can we change this smoothing model? Let's see. How can we change our model that we're testing to give us a better fit of the data to a linear model?
Could you do the same log transformation?
We could do the same log transformation. So we could put total in parentheses and put log 10 in front of it. And when we do that, we now have an R-square value of 89.67. So 0.8967, that's a way better fit of the data to the model than a R-square value of 0.414. So if we're going to do that up here, how do we have to change our figure? We can probably just do log 10. Actually, I didn't do it this way before, but it should work. There we have the logarithmic data, logarithmically transformed data. And as we can see, it conforms to the general shape that we had a couple of figures ago, but now we've just taken that shape and we've plotted a line. Now, is this a perfect fit of the data to the line?
No.
No, it isn't, but it's considerably better than it was. And once again, where it deviates is down in this area where there was probably a time when there are cases out there that we didn't know about. And that if we did know about, this would be closer to a linear fit than what we currently have.
So if you've got upsweeping data and you have the urge to do a log transformation, you have to do it in 2 places. You log transformed up there on line 14, and you log transform down on line 19.
Yeah, so this is actually running the linear regression. This is actually log transforming it just to plot the data.
So for the plot, all you had to do was in line 14.
Yep.
And that takes care of what you had previously done on line 17?
Yeah, that's why I got rid of line 17. If we did this, we would be like log transforming. We would be log transforming the axis twice, and that would just give us gibberish.
Got it.
Because you've already changed the logarithm. Logarithm 1 is 0, and the logarithm of 0 is undefined. And so it's not going to let you do that, which is why I commented out that line.
Okay.
So
it's like line 17 is changing your scale, line 14 is changing your data.
yes, that is exactly the difference. Yep.
Okay. All right.
Now, this is not the only way that we could have done this. We could have left the data alone, and we could have done something different here. I think this is how this will work. Yeah. So in this case, what it's doing is it's basically maintaining the scale here, and it's calculating the line as it would be scaled if you were dealing with logarithms. So you get this big deviation as the cases increase at the tail here. But if you then transform the scale to log, why is it? Oh, it's doing it because I got rid of the plus. It's not letting us do that. Oh, yeah, okay, it's not doing it because we've basically done a log thing. We've done a log here and we've done a log here. So yeah, it's not gonna let us do that. So yeah, so that was actually not a great thing to do in terms of graphing it. So we should basically just go back to doing this and get rid of this scale thing here. And that would mean getting rid of that plus and doing that. And so we're now back to yeah, so this would be a more reasonable way of graphing the data. And then these are the data. You could pretty these data up however you wanted to pretty them up in reality. And so because we have specified X as date here, it's actually treating our data as date. So it's giving us the first of every month, the 1st and the 15th of every month. And so it's treating it as date. And so you have a timeline that you can do, showing you that this is the log 10 of the total, and this is the progression of it. So this is another linear regression, and you can evaluate it in the same way that you've evaluated all of your other linear regressions. You can test it for fit. You can figure out what the slope is, what the y-intercept is. You can get the ANOVA model, the ANOVA data for the model, and continue on. Questions? Just for fun, this will just take a minute. Don't save because that was just practice. There are a bunch of people who code in R who have been doing a ton of work regarding COVID. And there is one app in particular that I found informative. And once again, the nice thing about these apps is that all of the code is transparent because that's the way R is. So this is a really involved R script for those of you in the data science world. This is something that you should maybe get into a little bit. This guy's written a set of sub-functions that go and get data from the Johns Hopkins website, and then if you just run the rest of this script, and it's long, it's long and complicated, It's basically a long function that they've done to calculate a bunch of things. Oh, but I'm not even to the bottom of it yet. If you run this function, it goes and gets the data. I downloaded the data yesterday because it takes about 20 minutes to download. And then if you run the Shiny app at the end, it opens a browser window. And in this browser window is a bunch of summary statistics on the virus. So in that programming language, in that script, they've actually applied an epidemiological growth model that will show you, here's where we are at, and this is where we're expected to go. It tells you what the total is with the latest data. The doubling time is determined by the growth model that is going on that predicts this. So every 6.3 days, we should expect it to double. This looks very much like our logarithmic data that we were just looking at. The fit of this is going to influence what the projection is like. If you're fitting data over longer periods of time, that projection model is going to have a tighter fit. As you move away, as you shorten that fit window, it's going to get narrower, so you can slide this back and forth. Our detection rate in the United States is abysmal, but there are lots of caveats with this. And then we can look at the growth rate. So actually, it's kind of nice because it looks like in the U.S. the growth rate of the virus is actually on the decline, which means that we're in the process of kind of flattening our curve because we're behaving in ways that we should. So this is just, I wanted to show you this as one particular application of R to something that's actually real world. And you can go and download this data off of this guy's, or this app off of this guy's website just as easily as I could, and run it through your own R. And if you're actually interested in what he's doing, all of his script is here. And so you can go and figure out how he's generating all of these things if you wanted to take the time to do that. And with that, we're out of time. Questions?
Does this guy have a link or a web address or something?
It does. I'll post that onto the Moodle site.
Okay. Good.
And then you can take a look at that.
On my calendar, it says that we have Zoom Friday and Monday, which is...
Oh, we don't. I just got it to recur Monday, Wednesday, Friday, because that's the normal schedule. But no, we are not meeting on Good Friday or Easter Monday. I will see you next on Wednesday.
Okay.
But as always, as you're working on your work, feel free to email me and set up a time, and we'll figure out what problems you're having with the work that you're working on.
Okay.
All right.
Can I stay on for a few minutes?
Sure.
Okay.
All right. I'll see the rest of you on Wednesday.
All right. See ya.
Enjoy your weekend.
Thank you too.
Sure.
So
all right, Grace, what's up?
With the report, the Gecko report.
Yeah.
I'm gonna share my screen with you real quick.
Great.
Where is it? Oops, I accidentally minimized it. Okay.
Yeah.
So this is the type of graph you want, right?
That's exactly the type of graph I want.
Okay, so I am trying to change my x-axis labels. This Summer Galveston.
Oh yeah, because that is not Summer Galveston. That is not Summer Oklahoma City.
Yeah, I want to change it to summer and winter, right?
Yep. So you do that in scale X discrete.
Okay, so I did that right here.
Uh-huh.
And when I try to run it, it won't do it. And I keep getting this error right here, down here.
Let's see. Yeah, that has to do with something else. Go back up to scale X discrete. So go to your help window on the other side. It's the place where your graphs are. It says files, plots, packages, help. Yep. Type in scale underscore x underscore discrete. Okay. Read through this. Go ahead. Scroll on through. Scroll on through. Scroll on through. Wait, stop. So aesthetics. Names the aesthetics that this skills works with. So what you haven't told it is you haven't told it that it's dealing with the X variable yet. So stop sharing your screen.
Okay.
I'm going to share my screen with you. And going to get rid of this browser window. I'm going to go back to R, but I'm going to close R because I want to go and access something else. All right, let's see. I'm looking for something.
Okay.
It was not in there. Sometimes it's just easier to go and find. I think it's that you have to do the limits. Oh yeah, try this. Try breaks. So this breaks thing is going to be telling it which levels are going in there. And so
Breaks equal C.
yeah, that's just concatenating. And your level, your things that you're asking it to do is whatever summer and winter are in your data set. So however they're listed as a variable in your data set. So try that and then show me what it does. I couldn't remember if it was breaks or limits, but I think it's breaks that you want to use.
It was breaks, but it's still
Okay.
like this. So
All right.
I did that.
Oh no, you still need to have labels in there though.
Oh.
After the breaks, after the breaks, put in the labels.
Okay. Labels. Parentheses.
Yeah. No. So after all that with breaks, at the end of the parentheses, after winter, do a comma. Yep. Now do your labels.
And do the same thing?
Yep. Yeah, you can click run anywhere in there, and it'll do it.
I think I'm missing a parenthesis somewhere. Maybe here.
Why does it say Summer Gal and Summer OKC?
I have no idea.
Because that's not even the data set.
I know.
Wait a minute. Okay, let me see your CI plot. Run the CI plot on the data that you have. Okay, so here, season population. All right. So now go down to your script doing the plotting. Okay, all right. Okay, just highlight 43, 44, 45, and 46.
43, 44, 45, 46.
Yep, but not the plus. Now run that. Oh, you have to, it's saving it as plot 1.
Yeah.
So you have to tell it to give you plot 1. So get rid of plot 1 for the moment while we troubleshoot this.
Okay.
All right, highlight those lines again and run them. Yep, there you go. Okay, so it's doing the right thing.
Okay.
Oh, okay. So for one thing, breaks, you have summer and winter capitalized, and summer and winter are not capitalized.
Ooh.
In your data file, but your labels you want to be capitalized, so leave the labels alone, change the breaks.
Change breaks to lowercase. Okay.
Yep, now run the 43 through 47 without the plus at the end. All right, change breaks to limits.
Okay.
Try it again. All right, give me a minute.
Okay.
All right. Try get rid of the limits altogether. Just go back to just labels, plain labels.
Okay.
And now you're gonna have to clean up your parentheses, I think. Yep. Yeah, there you go. Now run those lines again. Why is that still causing an error? Unmatched bracket. Yeah, looks like, okay, looks like that fixed it. Now run those lines. Click on the red dot, see what that's about. Okay, all right.
Is it labels equals C or?
Hold on. Ah, not that window. What is that window? Oh, you're missing an equals. That should be an equals, not a parentheses. Yeah, equals. Yeah, there you go. There you go. Now try that.
Oh.
There you go.
Okay, that was interesting.
All right. You need to change treatments to season.
Season.
And yeah, because that's the thing that you're actually looking at is season.
Okay. Not at population.
And here's another thing. I'm gonna copy a little snippet of code from something else. So I'm going to put this in the comments section, in the chat section
Okay.
of the Zoom, and then you can copy it and plunk it into your thing.
Okay.
But I'm gonna have to change some things. After scale X discrete, put this line of code in there that's in the chat.
Okay.
Now you can see it a little better if after the commas you can put returns. So after breaks before labels, yep, put a return there. Yeah. So now you can see the code that you've written a little better.
Okay. So it's giving me some errors. Do I need to
let me see your CI plot again. Just type CI plot anywhere. So season and population need to be lowercase.
Okay.
Oh, I made a mistake. In the OKC, there's a quote that's in the wrong place. Should be around OKC. Yeah, there you go. Oh, there's also one misplaced in Galveston. That Galveston needs to go on the outside of Texas, the quote. There you go.
What about?
Well, now you have too many over there.
Oh gosh. What? Oh gosh. Okay, wait. I know what to do. Oh my goodness.
Get rid of all the quotes. Oh, there you go. There it is.
Just have to like redo them, I think.
Oh, okay. Yeah. You copied from a little text editor and ours not recognizing it as code. You have to do that for all of these. They should all be green.
Okay.
Yeah. Okay. Do this. Get rid of all the quotes that are currently in there.
Okay.
I forget that you can't just copy and paste from text sometimes in R. Okay. All right. Highlight the word population and then press the quote button. Okay. And that population should be capitalized actually. Okay, do gal. Yep. Nope, but gal, the whole thing. Undo those quotes.
Oh shoot.
Yep. Now try it. Show me your plot. It didn't run the plot. All right, so you're having problems. Oh, you don't have a plus after the after that line that you just put in. You have to link it to the line below it. There you go. Now do it.
Do I need to put that plot thing back in?
No. What? Why geom line? That's weird. Run the first two lines of your code. Wait, no. Down to 47. Yep. Okay, now do the next line.
In addition to all those?
Yep.
It won't let me get that parentheses.
Get rid of the plus sign. Backspace to plus. Backspace all the way back. Yep. Nope. Go back to that line. Line 49. Now put a space plus. All right. Ooh, aren't you fancy? All right, now run the whole thing.
Okay. There we go.
Okay, now if you want to, you can also move that legend inside the graph with the thing look up online how to change legend position. And you
Okay.
can put it anywhere in the box, and then it won't squinch your data quite so much. But that does everything you want it to do, right?
Yeah. Okay, wait, I might have another question. A quick one.
Mm-hmm.
Oh, wait, never mind. Now my Levine's test worked. Yesterday it wasn't working.
Okay.
I think I'm good. So I'll move that legend box
Mm-hmm.
and I should be good.
All right.
All right. Thank you very much.
Sure, no problem.
All righty. See ya.
See ya.